Welcome to the demonstration of AC motor speed controlling system by using Android voice commands based. So here we're going to send the voice commands. So in stepwise 1 to 5. So those voice commands will be sent from the Android mobile phone application through Bluetooth. So the commands will be received by this HC05 Bluetooth module, and based on that commands the system will provide the pulse signals to this AC motor by using this BT136 triac. So here when we send the one command, the voice commands, so then the one will be sent to the here, and HC05 will send the number 1 command to the PIC16F73 microcontroller at B0 B1 pins. So based on the commands we are going to send the duty cycle signals to this BT136. So based on the duty cycle we are going to control the voltage to this AC induction motor. So directly based on that we are going to control the speed levels in 1 to 5 levels, and parallelly we are going to monitor the speed with help of this IR sensor. So here the black one is the receiver and the white one is the transmitter. So whenever this white surface come in front of this IR sensor, then this IR rays will be reflected by this white surface, and that will be received by this black IR receiver module, and there will get the pulse signals to the microcontroller at A4 pin. As we are using A4 as a timer pin, so we are going to calculate the rotations per minute, and that will be displayed on the LCD screen directly. So the LCD connected pin number B2 to B7. So remaining modules are, so this is the zero crossing detector. So if we want to control the DC motor, so this direct current, there is no fluctuation currents in a DC. So but in AC there is a fluctuation currents, it's alternating current zero. We need to find the zero crossing to control the. So as you know that AC has the alternating currents. So now, so when the AC signal crosses 0, so positive wave cycle we need to control, because only for the positive wave cycle so the load will be controlled. The negative wave cycle it won't control. So we need to detect the positive waveform starting point. So that is nothing but zero crossing. So here we are providing AC signal to this parallelly. So we are providing 230 volts AC, that is parallelly to the motor through this triac, and also parallelly to this transformer. So here we are using transformer as a step down transformer which will take 230 volts AC to 12 volts AC. So parallelly we are providing 12 volts AC to this DB107, so which is a full wave bridge rectifier. So after that we will get the pulsating DC. So the pulsating DC nothing but zero crosses pulsating DC. It consists of 12 volts peak voltage and 0 is the least voltage. So whenever the 0 crosses, the transistor will get switched on. So then this pulses will be given as input to the B0 of our microcontroller. The B0 is an interrupt pin. So whenever the 0 crosses, it came to know that the positive waveform is going to be start. So then the microcontroller will trigger the. So from the microcontroller we are going to provide the trigger pulses to the triac. Means we are going to on the triac based on the voice commands. For example, if you want to control the motor in first speed, means the level 1. So then when we send the one command from the mobile phone, so the controller will receive that signal with help of HC05. So then it will wait for the 0 crosses. As we know that AC waveform nothing but 50 Hz, nothing but 50 pulses per second. So in the 20 millisecond duration, the controller will capture the on time. Then based on the one pulse, we are going to divide the positive waveform. So positive waveform 10 millisecond, negative waveform 10 millisecond. So means 20 milliseconds per pulse. Then we'll get the 50 hertz, 50 pulses per second. So now we are going to divide the 10 millisecond into 5 levels. Means 2 milliseconds per level. So then when the 0 crosses, so if it is first level we need to control, then the only 2 milliseconds on time will be provided for the triac. So if the second level 4 milliseconds, like the 5 level nothing but 10 milliseconds, means nothing but full speed will provided for the AC motor, as we are going to on the full time for the positive waveform. So like that we are going to detect the 0 crossing detector, and also we are going to control the triac. So here we are using two modules, two ICs. One is a BT136 triac and MOC 3011 or 3021 is a diac. Means the controller can't provide the AC trigger pulse to the triac, as it needs a AC signal to get switched on. So that's why we are using this MOC 3011 diac, so which is optically isolated between the triac and the microcontroller. So the main flow is 230 volts AC inputs parallelly to the motor and to this regular power supply board and zero crossing detector. So after this zero crossing detector, the controller came to know the zero crossing timing, and this regular power supply board consists of bridge rectifier, filter and regulator. So bridge rectifier is used to convert the 12 volts AC to 12 volts pulsating DC, and the capacitor for smoothing purpose, and the 705 regulator will provide us the 5 volts constant DC. So after that, the controller will start reading input from the zero crossing as well as the Bluetooth. Based on the trigger pulses, the level signals, then the controller will control the on-time signal to this triac. Parallelly, the motor speed will be controlled. So let us see demonstration. Before on the kits, we need to install one application, that is Android Arduino Bluetooth control. This application will be available in the Play Store. This is the icon of the application. And next, right after installation of this application, now on the kit, so the initial message will be displayed on the LCD screen. Welcome to the project, and the speed 0 should not be displayed. So now restart again. Only welcome to the project message should be displayed on the LCD screen. Right now, go to the Bluetooth settings of your phone, and now search for the Bluetooth module. So there HC05, pair for that, it will ask for the password. So it will only ask for password in first setup. For next time onwards, it will be there in your history. So no need to pair again from the settings. And now go to the application. Right. Open the application. So it will be automatically connect to that, or else you can directly connect from here. So once pairing was successfully done, this light on the SC05 will blink slowly. Right, now it's paired successfully. Now click on the settings. This is the first time settings. I'm telling you how to initialize the voice commands. Go to voice commands configuration, click on the voice command. The voice command is going to be the 1, and data to be sent number 1. Coming to the 2, so you can change that. So just for easy purpose, I wrote the 2, because when I say the 2, instead of showing the number, it's always showing the TU. So for easy purpose, we can change that also. But the number data to be sent is number 1, number 2, number 3, number 4, number 5. But you can change the voice commands. So here I wrote the 3, but I wrote the 3 also for easy operation. So like that, we need to set 5 voice commands. Right, that to be set 5. So after configuration successfully done, now in this application, go to voice control. So there, so remember, when you are saying voice commands, only welcome to the project should be displayed on the LCD screen. 1, right. So the motor start rotates with level 1 speed. 2, 2, 2, 3, 3, 3, right. So we have configured tree for number 3. So that's why when you are, if you want to change that according to your wish, according to your voice commands, you can change that. 2, right. So another 2, second level. So every step we are going to increase that in 40 levels. 4, so it's changed again. The motor got speed increases. 5, so again here. Again we can come down to 1, right. So in this manner, through voice commands, we can set the speed for the induction motors. The working principle is, as we discussed, voice commands to the mobile phone application, and from there through Bluetooth to HC05, from there to the microcontroller, and based on the level which we getting from the application and on timing, then it is going to control the 2 milliseconds duration will be controlled, or on time will be controlled, so that parallelly we can